I'm Mary Claire Bristwa. I'm the Executive Director of the Technology and Applied Composition Program at San Francisco Conservatory of Music. Thank you for joining us tonight. Tonight is our first lecture as part of our ongoing TAC online festival, which is a one-week bonanza of master classes, lectures, and demonstrations from the field of music technology. Tonight, I'm honored to introduce Leonard Paul. Leonard obtained his master's degree in game audio with the CNAM in Paris, France in 2017. He received his honors degree in computer science at Simon Fraser University in BC, Canada, with an extended minor in music, concentrating in electroacoustics. He began his work in video games on the Sega Genesis and Super Nintendo Entertainment System, and has 20 plus years in composing, sound design, and coding for games, working for companies such as Electronic Arts, Backbone Entertainment, Radical Entertainment, Modern Groovebox Entertainment, Rockstar Vancouver, and Black Box Games. He's worked on over 20 major game titles, totaling over 6.4 million units sold since 1994. And it's our pleasure to welcome here today to lecture to our students. For those of you joining us on YouTube, welcome, and feel free to add comments or ask questions in the commenting section. Thank you, and take it away, Leonard.
Great, thank you, Mary Claire. That's awesome. I am very glad to be here, here as it is in, how do you say, cyberspace. So yeah, I'm very happy to be able to speak to your students and to speak to the public and basically talk a little bit about some of the work that I do in game audio and also in my sort of compositional work. So we have around 2-ish hours to work through different things, and I'm hoping to have a little bit of back and forth. So hopefully, I mean, I see a few little boxes on my screen there, and it sounds like there's other people on YouTube. So we'll also be taking comments in from the chat as well. So I'll just have to get those from, I guess, audio-wise from my the rest of the crew. So I won't be checking those exactly like me, but those will get to me. So yeah, I've been doing video games for a while now and working in audio specifically these days. As of, I guess, 7 years ago, I run my own school, like my own company that teaches people how to basically make a really strong demo reel so that they can present themselves and get work within the industry. And yeah, I also continue to work in game audio. So I'm working on a game called Eco, and it's pretty cool because it's like a game about the environment and balancing like the economy with the like sort of, you know, the nature side of things. So that's why eco, ecology, and economy, I guess. So both of those two balance out. And so it's available on Steam to try out, and it's primarily for use in high school classrooms. So it's a great challenge for me to bring in different sort of, I don't know, I guess you'd say different styles, I guess, of what, like with the music. I am going to compose a little bit, but there's also like existing music, and I've hired a composer, and then I'm going to be doing a little bit of stuff, but I'm also doing the sound design as well. So basically I do sort of all the things. So that is what I do these days, is basically I teach and I work in the industry. So as far as presentation, hopefully the presentation screen is up there. It's all good? Yep. Okay, cool. Great. Thanks for nods. That's very helpful. So yeah, this is the talk is basically talking about pure data and game audio. All right, and so there's the site, and my Twitter handle's at the bottom in case you want to tweet at me. And as far as getting started with things, what is pure data? Well, what I'm going to do is I'm just going to blast through a whole bunch of different things so that you can just sort of see what pure data is as far as sort of my own practice, I guess you'd say. And so I like to, yeah, like play around with a lot of different things. So not all of these are going to be specifically about working in like games specifically, but it's using this language called pure data. And so yeah, like just a general overview is that pure data is a visual scripting language, so it allows you to produce different behaviors, different audio. It can, like, you know, combine audio with MIDI and basically make different behaviors dependent on that. So I can do all sorts of different things, and I'll instead of trying to give you a general idea that way, I'll just dive right into some examples here. All right, so we'll start out. Well, I can start out here with let's start out like sort of classic style. So with this one, I'll play this video. Hopefully it will be. I'll try and make it full screen so it's a bit bigger. Okay. There we go. And so what I'm doing here with this is that it looks like a lot of boxes and lines and stuff. So you can kind of see it as being like, objects and functions that are connected with lines that are, it's kind of like audio cables or MIDI cables. And so it allows you to communicate between those functional objects. And within this patch, I've got like on this side over here, I've got like a sequencer, and it's got like notes that go along the right-hand side. And I'm using another, like this is a pre-built module that this guy Martin Brinkman did. So you can actually download this and get access to it. So what I do a lot is that I don't necessarily make my stuff from scratch, is that I use pre-existing things, and then I sort of carve off the bits that I like and the bits that I don't like, and then I make my own things from there. So the sequencer is here, and then over here I've got different scales that I'm sort of filtering the notes through. And then down here is the mixer, and I've got a piano player here that's using some not so great piano samples, but anyways, let's just have a listen. All right. So my idea with this piece was all of this, the examples that I show will come from this sort of, I guess you'd say sort of art kind of concept called Noisevember. So it's just sort of similar to like Inktober, where artists that are visual artists, they produce a piece of visual art each day. But for Noisevember, what you do is you produce a piece of like, music / audio each day. So this is just a sketch that I did within one day. So, it took me a couple hours to put it together, basically. So you basically get the idea there. Okay, and so I'm using different random sort of stochastic processes, and then I've got this sort of gesture that I'm using here to move through the different styles of, like where the notes are. So here the notes sort of start out low, then they go high, and then down again. And so it gives a contour to sort of the actual pitch of the whole piece. I'm just going to keep firing through here. If you have questions, I guess feel free to let me know. Otherwise, I'm just going to keep blamming through here. This one here is more sort of old school electronic style. So this one is probably going to be a little bit louder. So maybe I should trim this a little bit, and then I can bring the level in more. So with this one, more lines, more boxes, but here I've got like electronic drum machines. Over here I've got some sequencers. These are stretching things out, and it sounds like this. All right, so it's sort of like the sample at the beginning, hi-hats, right? Okay, and eventually we got to bring in the beat. Come on, man, bring in the beat. Okay. So it's like a 303 kind of sample type thing. All right, always fun. And then I've got the kick drum over here. And so it's another hi-hat. There's a kick drum. All right. And you can see that it's a little loud too. All right. Okay, so that's old school beats using pure data. And as far as the relationship to game audio stuff, I can actually put those into pieces like I can put them in interactively, and I'll show you how that gets done later. I've got some other ones here. This one is like a synth demo, And so this one I'll actually boot up PD, and then we can see it live. So if I click on this, let's see if I did it right. And okay, it looks like that. And I'm going to turn the DSP on, and then we should hear these two synthesizers sort of going from the left to the right, sort of sound like they're arguing. So this is, once again, another Noisevember experiment that I did. So it took, it didn't take that long to make it, and so you get the idea here. So with this, we've got, there's sort of the, more like male, like lower tones on the left-hand side, and then on the high side, that's like, there's some discussion going on here. Don't know exactly what it is, but, the idea being that all of this, it's all math. So it's all just numbers. So we've got random numbers coming in through the noise here. So I can actually, edit this and move it around if I wanted to. And then from there, we go down here, and on this, I use the random noise generator and put it into a sawtooth wave here. And with that, eventually it goes through a filter, and I can change the frequency of the synthesizer, and then it just goes out here. Okay, and then you can see it moves around, and they talk to each other. Okay, so that's sort of another experiment that I did for Noisevember. Okay, and let's see here. Oh, I see there's one. Oh, there's a chat. Wow, I can even see that. What did one droid say to the? I know. I'm not exactly sure, but you gotta answer that question. I'm not gonna answer that one for you. I'm gonna keep going because I got so much PD stuff to do. It's incredible. So with this one, my background when I was at Simon Fraser University in electroacoustics, I did a lot of work with granulation, so granular synthesis with Barry Truax, and so here's an example of using granulation. So with this one, all of the sounds are made using a glass sample, so this glass drop. So actually, maybe what I'll do, instead of playing that one, I'll load that one in here. Okay, do people know what Paul stretch is? It's okay, so it's a way of taking the frequencies of the sound and then like expanding them and stretching them, like, maybe even like hundreds of times longer than they would normally sound. So it's not exactly granulation, but it does a frequency analysis of the sound, and then it finds out what frequencies there are, and then it just extends those for however long you want it to play. So let me load this one up. Oh, I got another window going on too. Two things playing. Sorry. Let me shut that guy down for now. Okay. Alright. Woo! Man, that's big. Okay, so you can see all of them are using this glass drop sample. Okay. And then down here I've got a spectral analysis happening. So this is the low end down here, and then it goes to the high end up here. And then if we want to see what sound each of these are making, I can actually just delete them for now. So I'll take away this one. You hear that the sound changed, right? And I'll take away that one. Okay, so you hear that this one up in the top is sort of the high frequency, right? Yeah, okay, cool. And I've also got like just straight samples of the glass being dropped, so you hear that like that one, right? Okay. And so those are sort of the two layers that are happening right now. And if I bring back this layer, this one here is like low, because if you look at the transposition, it's down 2 octaves, okay? And then I can add in the last layer again, all right? And this one's down 3 octaves, but it's also going up and down. So I'm using a different function that actually can bend that sound over time. So this is something that commonly happens with electroacoustics, where you kind of take an existing, sample either of an instrument or a sound, and then you figure out how to make something musical out of it. Okay, So once again, this is Noisevember, so I didn't spend more than a day working on this. Okay, so there's that one there. Okay, that one's kind of fun. Let's keep going. All right, and oh, there's a cello one that I stretched out. This one, that one's cute. It does pitch detection using a slide whistle. This voice resynthesis one is a bit more technical. That one's a bit kind of craziness. Oh, okay, and then this one here, automatism, is actually automatism, sorry, is kind of cool because this is it's a program, oddly enough, that's written within Pure Data, and it allows you to whoopsies. Yeah. Right. So if we take away chunks here, because this is fairly basic, let's just get rid of these ones. All right. All right, so with this one, I don't know, how's the resolution there? Should I try to make it bigger? Like I can double it? Is it better doubled? Yes, no. I see a lot of like...
It's pretty easy to see here now. Yeah.
Okay.
I mean...
If I make it half size, then is it intelligible or not so much?
I think it is, personally.
It's okay?
Yeah, it's very clear.
Okay, all right. Well, I'll leave it at the zoomed out then. Okay, so with this one, you can download this system for free. It's called Automatism, and there it is in the top left corner. And so it's a sort of like a synth patching environment that's made within Pure Data. And it's sort of like if you know modular synthesis, right? Modular synthesizers. It's sort of that similar concept of where you take, you know, control voltages and you put them into different things, and then you can have audio rates things, and then you can listen to those and send them to filters and stuff like that. So similar to working with modular synths, you have a clock here, and that's generating like a tick outwards. And so if we add this, which is what I did before, that was a 303 type sound. Okay. And if I wanted to do that just on my own, I could also just go here, click on modules, and then here there's a whole bunch of oscillators, you know, all these different things. And I get a 303, and yeah, that super didn't work. Where did that go to? I thought I clicked on it. Where did it go? See, that's the lovely thing about working with live demos. Let me try it again. Click. Oh, goodness. Okay, forget it. Let's just do that. Okay. Pretend that happened in the way that I wanted it to. So with this, it's like a 303, sort of like a Roland baseline simulator. You know, it's all nice and juicy. Used a lot of electronic music. All right. And then if we add here a sequencer, I can make this one go into a kick drum. See? There's the kick drum. It's going into channel 2, so I can also change the mix on this. See, I took out that. And this thing is a little loud, so let's tune that down a little bit. Okay. I can play around with that, and then I can add the snare drum here, and I also added a comb filter as well. So it's just sort of a different type of processing. Basically, it's a very short delay line with a high amount of feedback, and you can tune it to pitches if you want to. So I use that a fair amount in my own music. So if I turn that down and turn feedback up, let's see if we can just get the comb filter. Here. I know that'll get annoying after a while. Okay, and so this is what the comb filter sounds like if we, right? You hear how that works? Where it was originally like a snare sort of sound, so like there's broadband noise in there, and then if I put it through the comb filter, it sort of tunes it to the length of the delay line, so I can hear it sort of bending around, right? Right? So yeah, fun stuff. So there's Automatism. You can try it out, download it for free. I'll have the link in there later. All right. No. And let's see, what else can we do? Okay. Oh, speaking of 303s, this one was super fun. I won't play this one for very long, but anyways, this one I do like. So this one is using modules by Martin Brinkman, and so this is another Noisevember sketch that I did. And sort of it simulates the sound of a 303, but I spent a lot of time trying to get the distortion happening right, so... Ooh, yeah, that's nice and loud. Maybe I'll go like this and turn that down a little bit and fade it in. So yeah, it's kind of juicy. So yeah, you get the idea there. Anyways, I enjoy the 303. Everybody loves a 303. This one here, if you're more interested in traditional composing, with one of my students, he was trying to figure out a way of moving between different chord voicings. And so I helped him out by making this patch. This is another Noisevember thing. So with this, basically it takes chords in here, so I think it's a pretty basic chord, and you can see the intervals here below, like these are kind of like the MIDI note numbers. So you've got like, 0, which is like the root, and then you've got like the 11th, right? So that's like 11 semitones up, and you've also got the 4th and the 7th. All right, so if we listen to this, it sounds like this. So these are all in like in half steps, based off of the root there from 0. Right? So there you go. Basic chord, right? And so what it's doing is it basically just takes it, anytime there's a note that goes beyond the octave, it's wrapping it around now. Okay, so it's changing that particular chord voicing. And it's just doing it using the math stuff here with PD. So it's taking that, like I think it's a major 11th or something like that. Anyways, it's cramming it into one octave. But then what I can do here is that I can, if I change this offset here, then I can move that octave down lower. So here it's like, like it's 7 semitones down. So it'll sound like this. So now, okay, sorry. It's actually using the octaves here. This is making the octaves go up, right? So you see the numbers go up here and the chord goes up, right? And then I've got, I can also spread it out more. So this is across 3 octaves. This is across 3 octaves this way, right? So hopefully for people that are more compositionally minded, this is kind of like a cool thing that you can do with PD. It doesn't just have to be like, synthesis. It can be also MIDI as well. And you can do real-time MIDI processing, and you can make your own real-time MIDI processing VST plugins if you want. So does that sound interesting? Yeah, okay, all right. Yeah, we'll see. I'm going to hopefully get there. I think it's pretty interesting too. So I just wanted to show you a lot of examples at the beginning here to give you an idea of what it can do. So here, this one is another Noisevember thing that I was playing around with, and this one simulates the sound of, what it does is it does a spectral analysis of a bird, like a bird song. In this case, it's like a Stellar's J. And then it looks at the pitches using, the pure data object called Sigmund here. And then from there, it figures out the different partials. And from that, then I can resynthesize it by looking at those partials and then assigning a synthesizer to those partials. So what does that sound like? So you see PD partials. And this might be a little annoying because Stellar's J's, they're like kind of an annoying sound, but I love them. I had a couple in my backyard. There's like, I think they were like brothers or something. They're flying around each other a lot. So you hear the higher tone is the synthesized one, and the lower one is the original one. This is all synth. This is the crossfader here between the two. And there I'm bringing in the original sound. So there's another. That's just synthesis. It's a combination of the two. That's the original sound, far to the left here. It's a combination of both. And then that's just all synthesized, right? So, that doesn't necessarily have a lot to do with like working in, like music, but with game audio, it would be kind of cool to do an analysis, like, looking at the, different frequencies and then a resynthesis, which is what that is. And the cool thing with PD is it does it in real time. So you can hear what the quality is as far as like the emotional sort of, the evocativeness of it, right? Okay, so let's bring it back a little bit to working with games and game audio. What you can do is that you can use a program called Wise. So that is, it's a game audio middleware, which basically means it's an audio engine for video games, and you can use it in other middlewares, so other game engines like either Unity or Unreal, or just in, like if it's the game's coded in C++ or whatever, then you can add this audio middleware, which is like an audio engine called Wise. And with this, you can use pure data and you can compile plugins for Wise, which is really quite neat. So what I did here, which was actually quite easy, is I made a Ring mod plugin for Wise because they didn't have one previously available. So I did this in a matter of just a couple hours. So I don't think I show the PD patch in this one, but I show what it looks like in Wise and what it sounds like. So this is just running dialogue through the Ring modulator that I made. So it sounds like this.
You did it! I can feel the evil energies. The darkness has been vanquished.
One hearty pickaxe that has served me well.
So there it is, fully processed on that side, right?
No, we did not defeat evil, we set it free.
So you get the idea is that you could use that for processing, dialogue lines in real time, and you could make some sort of, I love droids, but yeah, like some sort of robot sound out of that, right? Okay, so as far as like a basic I guess you'd say an overall introduction, that's sort of where we're at now with PD. Does that give any questions at all? Any questions? I'll leave a little space. I guess either we can use audio, or I guess we can use the chat, or I can get stuff in from YouTube. It's up to you.
Just a brief question in regards to PD and Max MSP and all that. Would you say that the two are comparable in terms of, if you know Max pretty well, do you think someone would pick up PD?
Yeah, definitely. It's kind of like French and Italian. It's kind of like they literally have the same root language. So Miller Puckett was the guy that basically started out making Max at that time, and MSP was sort of the audio components of that. And he split off and started doing his own thing, making PD in the mid-90s. And Max MSP sort of, continued to be sort of the more commercial arm. And it's sort of the prettier, and like it's got better documentation. And they've also, like Cycling 74 is a great company, so they've done some amazing work with it. And then on the other side, you've kind of got like Pure Data, where it's kind of like scruffy and it's a whole bunch of like open source developers and stuff, and it can be very messy. But the cool thing is that with the heavy compiler, like I'll show you later on, is that you can compile Pure Data plugins and actually use them in VSTs as Unity plugins, and whatever else you can compile to like C or C++.
Awesome. Thank you. Thank you so much.
Cool. Thanks for the question. Yeah. Any more questions? Yes. Hello.
Before, when you were showing us the example where you were re-synthesizing the bird audio sample, could you maybe, for some of our viewers at home who are not super experienced in working with technology in a functional way, like making a game, maybe you could give an example of a situation when you would need to re-synthesize the bird sound as opposed to using the original sample. You showed us a creative application, and maybe could you talk a little bit more about a functional application where a tool like Pure Data becomes really useful?
Yeah, so I think that brings up a good point that pure data, like if I'm going to use it, say for synthesis, then using and creating sounds via synthesis has its own aesthetic. It has its own artistic kind of, way of conveying a feeling, and it's not necessarily the best thing to use for everything. Like, it's just not needed. Like, not every single like film soundtrack should be like an electronic score, or not every film soundtrack or game soundtrack should be, like an orchestral score. So it's trying to figure out how to fit, these tools to the overall, your overall artistic vision of what you want to put into the game. So say like with that example of like the bird sound, with that, as far as trying to think of a way that I would use it, it might be where I'm working on a game that's like set in the future, and it might be to do with, like a sci-fi kind of context where you are going to like alien worlds and you want things to sound sort of familiar but like weird, like, kind of unsettling, where people have heard the bass sound and you want to have that, like that quality of the way that like that Stellar's J sound like really comes through, and I like how intense it is, and you can get a lot of mileage out of using real world sounds to drive synthesized sounds. So for a video game, it would also allow you to create like limitless, sounds, because you could, once you have the parameters, then you can play around with those, and then you can lower the pitch or make the pitch higher, and you can get all sorts of different creatures just out of, a small amount of sort of like seeds. And so a lot of the times in like my own like music work, using Pure Data and otherwise, I try to figure out different processes that create an interesting world of possibilities from just a small sort of, source, sort of grain, I guess you'd say, or like a small amount of information to begin with. So I hope that gives an idea.
Totally. Like the games that I really enjoy most are the ones where I don't hear the same sounds over and over again, where they're arranged and it's very fluid. It makes it feel very real, as opposed to just hearing the same bird sample triggered over and over again.
Yeah, and it's the thing when working with video games is that they run on, computers that have limited capabilities. So even if it's a PlayStation 4, it's still a computer. And so on the audio side, if you're trying to make things sound very, where there's not a lot of repetition, then you could sample like, whatever, 100 different bird sounds, and then you just put all the samples in there, but that takes up a lot of memory. Or you can do the pure data side of things and like, actually do an analysis of all those and then generate a whole bunch of them. But then you're having to be concerned about the computational power, so the CPU, like the processing load, because the game is doing a whole bunch of other things at the same time. So you have to balance your sound design and your music, if you're, generating it through synthesis, with those kind of concerns. So that's something that I deal with, like in games a lot, is balancing repetition, memory, and sort of, I guess you'd say like fidelity, or, how convincing a sound is, with the physical, limitations of the game machine.
Awesome. I think this is a problem composers have dealt with for a very, very long time. Even writing for a symphony orchestra or writing like a trombone piece, you have to always look at a student work and say, I think that the player might fall over in his chair if you make him play those 16th notes for that long without taking a breath. There's definitely a 100-year history of composers thinking economically about their creative and artistic choices, and it's fun to see it kind of extend itself into the digital realm.
Yeah, and I like to sort of think of it sometimes as where the computer is kind of like, my player, sort of like thinking that they can, the computer itself and the process that I put into either Pure Data or other, systems, it actually gives me back sort of more than I put into it, similar to like working with live players.
Oh, hi.
Oh, hello. Yep.
Hey. Yeah, I just kind of thinking of some, small questions. One is, so in your sort of workflow, do you like typically build like Pure Data plugins that you integrate into Wise and then like go from there to Unity, or do you ever like build things that go directly into the game engine? And then I'm also just like generally like, this is the first time I've ever heard of anybody using like Pure Data for game audio, and I think it's really cool. And I'm just kind of curious how common it is, or if it's just like a thing that you specifically do.
Yeah, no, it's weird.
Okay.
Yeah, it's not common, and part of it, the main reason is that although the thing that I really love about Pure Data is that it's like it's interactive, so you add like those, like I was adding the kick drum, and then you hear the response right away, which is cool. When you're working with languages like C or C sharp, like if you're working in Unity, you don't necessarily hear those changes right away, and so there's like it's kind of like, oh, okay, I'm gonna like write down some changes in the sheet music, and then I'll hand it over, and then they'll look at it, and then you start at the whatever bar 1, and then eventually you'll get to the 17th, and you'll be like, oh, okay, there's my change, kind of thing. Yeah, so it's a lot less immediate than sort of going like, oh, hey, everybody, like, in sort of a jazz context, just like, okay, switch to this, and then like, a drummer cuts out, and then like, yeah, I just want to hear the trombone playing those 16th notes. It's just like jamming with stuff like in real time, to me, helps keep the sauce warm. Like it's trying to preserve your creativity in the moment. And I like PD for that. And so the thing that it's good for is that it's real time, but the thing that's not so good for is that's not usually optimal from a computational standpoint.
Yeah, that makes sense.
It's constantly reevaluating the whole patch, like all the time, to go like, oh, did you move this over here? Oh, I need to like to display this now. And so when doing that, the way that the language is it's not necessarily that optimal. So the cool thing about the Heavy compiler is that they actually approached that as like one of the core things that they needed to do, was to make it optimal. So they did some very tricky and cool things. And the neat thing is that it's all open source now and available for free. So we'll look and listen to that like later on. So yeah, what I'm doing is kind of weird, but I mean, I've been using PD since the mid 90s, and I've been talking about like when I started teaching game audio, like almost 20 years ago, I actually built my own game audio engine in Pure Data because like Wise did not exist. And so I wanted the students to be able to be like, oh, put this sample in and you can hear it right away. So I was trying to figure out ways of making that jamming process, like the latency, like the feedback loop, fast as as fast as I could.
Yeah.
So that's why these days, now we finally have the processing to really be able to do it. But of course, that also means that all the graphics and physics and everybody else is also vying for like, all those PlayStation 5 cores as well. But yeah, like with real-time sort of, VR audio processing, that is the kind of processing that is making these kind of things more possible. So gotcha. I think that really more so what we'll be running into, rather than a technical limitation, is more like a perceptual / just skill limitation, where people are like, oh, hey, I know how to put in samples, but I don't really know how like analysis and the resynthesis works. So like, it's sort of the difference between like people that maybe were stuck using like like tape machines, and then the computer came along, and it's kind of like making that leap from like static 2-dimensional kind of samples to like things that I think are a lot more reactive, like we're either synthesis or using PD even with samples. It doesn't always have to trigger synthesis, like I showed in that like the piano example, right? And other examples as well. Yeah, so I hope that addresses your question.
It does. Thank you. Yeah.
Great. Okay, I'm going to continue on here. So if there's questions, you can hang on to them. I'm going to do a little break soon enough, but I'm going to go back to the presentation because that way, hopefully, we'll get through most of the actual presentation. All right. So yeah, what is PD? Let's switch back to that. That's the presentation there. Okay, so yes, open source visual scripting language. And what does it look like? Well, it looks pretty ugly. So if you want to download it, the link is there. So it's Miller S. Puckett at University of California, San Diego, EDU, education. So yeah, basically that's where Miller Puckett, the guy that wrote Pure Data, and the vanilla one is sort of the main route that he's done. And so it's the one that will compile within Heavy. There's another variant called Pur Data, P-U-R-R, which looks a little nicer, and it's kind of like it's got more objects in it, and it will also run the same patches, but if you want to compile it, then there can be issues. So if we just make sort of like a hello world program in here, I create a new page, and oh my goodness, yeah, that's like super boring because there's nothing in there, right? So let's I think with Max MSP, I haven't used it in years, but you get a whole toolbar at the top. You know, there's colors. PD is just black and white. And, you know, what are you going to do? So here, if I create an object, the way that I did that is I went put object, okay, and it creates a little box. And then I can type in there. So I'm just typing OSC, which stands for short for oscillator, which is going to be a sine wave. And then I'm going to make it at 220 hertz. And then I can create another here object. There's another one. And then this is going to be our digital audio converter. And the little tilde afterwards, I think it's meant as a little bit of a joke, but it's meant to be that this is an audio object. So it's supposed to look like a little sine wave. Sometimes it can be problematic because the tilde object is kind of hard to get to on certain computers, especially laptops. So when teaching students, it can be a bit annoying. So there we go. Let's zoom in there and get a better look at what that is. Okay. So we have this, and then we want it to go out the output. So we get this little donut here, and then this is like doing our patching, and this is the left inlet. Ooh, yeah, there it is. And then I go like there. Ah, so loud. Okay, so that's loud. It worked, right? You heard that? Boo! Somewhere around there. I have perfect pitch. So let's go like this. And what we want to do is that it's good to sort of see with Pure Data is that it is just numbers. And so it's all mathematics. And what I want to do is take the numbers that are coming out of here, and there it's just it's a regular stream of numbers between -1 at the bottom and +1 at the top. So when it goes like this, up and down between those, it does that 220 times per second. You know, it goes through a full cycle through those numbers, and that would be analogous to, like, you know, pushing a speaker out at that, you know, same frequency. Okay, so I can select this object, and I'm going to do command 1, and then that, see how that automatically created a little connection there? So that's a little shortcut. And then I do times, which is like the asterisk, and I'm going to take it down, you know, like a lot. So I'm going to take it down a tenth. So if we multiply by 0.1, you know, 1 times 0.1 equals 0.1, -1 times 0.1 equals -0.1, okay? And so instead of now going from this, which is what the OSC is spitting out, now we're just going here, right? So that's going to change our volume, okay? So if we go like this, now when I put this together, it goes like nothing. Oh, because I forgot to put the little tilde there. So right now I took this, and it's like, oh yeah, for sure. I'm going to take audio in, and then I'm going to spit out this skinny cable, which is, you know, it's actually a stream of numbers, but not audio. So it only outputs when it needs to. So I need to tell this audio. Okay, now if I do this, see, the audio cable's all fat. Oh yeah, there we go, left and right. Okay, so that's kind of like a hello world kind of program in PD, because I know I threw you a whole bunch of like, whatever, complicated patches, but when it comes down to it, you just got to start from the basics. All right, so I'm going to leave that. That's PD there. No, I don't want to save that. As much as it wants me to save it, I'm not going to. Okay, so yeah, similarly, there you go. I did that OSC 220 into the DAC. All right, and then, per data. Okay, let's have a look at that. I'll open that up. Yellow. Okay, I guess I got a window out of here. Sorry. Go like this, and then go per data. And this one here already, you can see it's a little nicer. It's got, whatever stuff that it's spitting out. And so the advantage of per data is that it opens up a whole bunch of extra, what are called extensions, which just means that there's more functions that you can add to it besides the really minimal, like plain vanilla core. So if you want to play around with this, the best thing to do is just go to the help menu, go to the help browser, and in here you can go through the control tutorials or the audio tutorials, and you can look at patches in here. If we, there's a whole bunch of them. Envelope follower, analog sequencer, that kind of could be interesting. Analog style sequencer, sure, let's open that up. And it looks like this. Yeah, it looks like there's a lot of stuff, but you can already see like the audio cables are like twisty, so they look kind of nice that way. All right, and if I turn this one on, sounds like that, right? So it's going through, I gotta move this out of the way. It's going through this here, it's taking this table in as notes, and I can change the table in real time. Okay, so if I change this, it should, see, the notes change, right? So once again, pure data is just like quite literally pure data. It's just taking these numbers in and using those as notes, or you could use them as, velocities or whatever. Okay, so one of the nice things about pure data is that if you're like, yeah, that's a great patch, I really like that, well, then you can create a new patch, and then you can just take all the good stuff that you like. Oh, I probably need that, and I can copy that. I don't guarantee that all of this will work, because sometimes you need to initialize stuff, like you need to set it up properly. But if you like that, you can close down the original and then paste this over here. I've made a bit of a mess of it. Okay, and then there it is. So I can change this if I don't want all this extra comments type stuff here. I'm like, no, I totally understand this patch. I'll never need those again. And you can do that. Change this. Okay, and maybe, gosh, what else could we do with this? I mean, there's all sorts of, we could, I don't know, try, what happens if we do OSC at the top? Whoa, yeah. That's weird. Okay, that sounds great. I really like that. So now I can save that and put it into my documents and go like, I like this 00, and it's a pure data patch. I go save. There we go. And if I close down per data, I actually should be able to load that into pure data. I actually have never tried this because I don't use per data a lot, but let me try and do that. Documents, where's the I like this? Open. Turn the DSP on. Okay, that's good. Oh, it doesn't know what the output object is because that was in a different area, but I could just put DAC in there, and like we did before, I could just do a multiplication here. Take that down. I don't know how loud it's going to be, so I'm going to scale it down a little bit. Okay, I try not to patch too much stuff. Oh yeah, there we go. So nice. So you can see that PD and like pure data and per data are compatible. So in general, I mean, the per data has extensions which you would need to manually add to PD, but in general, yeah, same thing. Okay, cool. So let's go back to the presentation over here. So that's where you get it from, per data. All right, and oh, this is fun. I'm gonna play some music. How's that? So how are we doing here? We are part of the way through. Yeah, we're good for time. Awesome. Slide 5 out of 24. 1 hour left. No, we're doing fine because I'll be able to burn through a lot of stuff here. Okay, so I've got PD here. I don't have any windows. That's fine. La la la. Where should I open this from? So what I'm gonna do is open up a patch that I basically used for the Beep documentary. So it's a documentary film that I worked on about 3 years ago that describes the history of video game audio. And so what I did is I did the entire score using pure data, well, basically the entire score. And so, whoopsies, sorry about that. Over here, if I click hello on this, then it'll bring up the Bandcamp. And so with this, yeah, there's about 20 tracks or so on there. And yeah, I was able to yeah, basically put that out with the DVD. And yeah, it was a really interesting project to work on. So I'm going to load in one of these called Cruising the Cosmos. Yeah, maybe I'll do that. I think that was the one that I've used before. Yeah, Cruising the Cosmos. And so I did a 2-hour performance with pure data using the Leap Motion. You can't see it, but it's down there. It's basically like a sensor that's able to figure out where my hands are in 3 space. So it's up, down, left, right, and then like, you know, sort of in and out. And it also knows if I'm tilting my hands or if I'm putting my hands together or making, you know, fists or whatever. So it does sort of, you know, I can sort of make it figure out gestures. So yeah, I did a 2-hour performance at an art gallery near me. I live up here in Vancouver, Canada. And boy, were my arms tired. But the main thing is just that, you know, it's like a lot of the performance is like holding it like this, which I like it for the intensity, but also it's kind of like, you know, it's if you play like real instruments, then you know what it's like. If it's like violin, you got to get technique. You know, if you're going to play for 2 hours of whatever it is, you got to be careful of the way that you move your body. So I need to load this one up first. And this performance was in quad. So yeah, there might be times that it fades out because it goes to the rear speakers. So apologies for that. I didn't have time to repatch it. And as you can see, a lot of the times when I'm working at stuff, it's kind of like a soldering like table, like a workbench, and it's kind of messy. I don't, you know, anyways, we don't necessarily need to look at that. This is nicer. That's like a little bit more coherent. And then if I load the actual patch, it looks like this. And yes, that's right. Actually, we premiered Beep at SFCM like, oh wow, 5 years ago? Whew, okay, all right. I guess it's been longer than I thought. But yeah, it was really nice to see, yeah, just people from the community come together, and it's very how do you say, nerve-wracking to be in the audience during a premiere. So yeah, hopefully the level's okay here. I guess I can bring up the level a bit. Okay. All right. So basically, what I'm doing here is that if you look at the, I think I can zoom in. Okay, yeah. If you look at the top left here, what I'm doing with my hands is that, you know, you can see already it's detecting where my hands are. So it's able with my, hopefully this hand here will detect where the scene is. And this hand here will detect the mix. Okay, so I'm going to move the mic a little bit out of the way here. Okay, a little down. It's going to be quieter. Okay, so the thing that I wanted to do let's do the whole thing. And you can hear it sort of goes between shuffling and non-shuffling. Sorry, I'm going to have to start from a known spot here. Okay. Okay, something like that. Okay. All right, so right now I'm on scene 1. And then if I move my hand up and down, you can see that it changes in the bounds, right? In the top left where there's that green thing, OSC scene. And if I move my hand up, then I'll go to another scene. Okay, like, and now it'll change. Okay, there's different notes in there. And with the right hand, I will be able to control the mix. So I can cut layers in and out with my hand. I'm gonna turn it up a little bit, and maybe talk a little less. Fade it out by moving my right hand up. I just fade it out, and that's kind of a nice gesture to end things on. And you can see there's a mixer here where all the levels are falling. All right, so I butchered that, but that was because I wanted to go through it quickly. And also, like I say, that the problem is that it's meant for quad, so I can actually grab the quad mix and move it around with my hand, like using my fist. So sometimes it detects it incorrectly, but it always snaps to the middle. Okay, so let's get out of that one. Let's go back to the presentation, continue things, and you can ask questions about that a little later on. So let me get, the mic back in the correct position here. All right, I could just get it a little bit into screen. Okay, great, there we go. All right, there's that. Okay, and so yeah, if you're interested in learning PD, this is a great book. It's called Designing Sound. It talks a lot about doing basically like procedural sound design, figuring out how to use mathematics to generate sounds. And yeah, Andy Fornell has been doing that for a long time. And it's nice that he did it in pure data, and he's basically made his patches available for free. So that means that, there's like little honeybees and like, whatever, like I guess it's a hummingbird, helicopters, and you can synthesize those using pure data. And you can see how they're actually made in that book, and he does a great explanation of that. The patch library that I used a lot with that previous patch, the Beep documentary one, I use a lot of Martin Brinkman's work. And so one particular patch that I will take out here is that I use that 16 by 16 sequencer a lot. You can download that from his site, and I'll show you what the original sounded like and looks like. So if I go onto here, pure data, and I believe it's in coursework. There it is. And Martin Brinkman. Okay, here it is. So this is the original. So you can see the difference between sort of what I've done with his modules and also my own modules and sort of where it started. Excuse me. A little loud there, sorry for that. Okay, so you can see that there's the 16 by 16, right? And he's got different ways of doing shuffle and swing, and then he's got different instruments, and then he's got his mixer here as well, right? So similar to like working with, if I take elements out here, right? I can fade things out on the mixer. Okay. Okay, there we go. Yeah, nice. Is that like, you know, using Reactor or something like that, is that you can take those patches and then use them for your own, which I find pretty cool. And he has a fairly, I'd say, generous like licensing. I think it's LGPL, so it just means that you can kind of freely use it. Just, you know, make sure to say that you used his work, and yeah, he just wants to create some cool patches for people to be creative. So as far as producing interesting things, you know, making a sine wave isn't that interesting, but using all these functions is pretty cool once you get into the hang of it. All right, so there's that. All right, and okay, so what we can do here is that when working with more so like if you're just, you know, not so much for like game music, but if you're just hoping to use pure data for like in your own music, then you can actually make VST plugins really easily. So I will try to show a little quick demo of that. Okay, where to begin? All right, so where is this? This is, what's the fastest way to do this? Okay, so if I go here, and I can, actually it's easier if I do a search. Sorry, chamomile, there we go. There it is. Okay, and already there's all the little bits and pieces that you need. And if I look in here, this is where the pure data stuff is actually, no, I lied. It's in examples here, sorry. We go into examples. You can create plugins that are, you know, synth plugins or effects plugins or even MIDI plugins, which is neat for MIDI processing. So if we play with this one, this is a reverser. So if we open this one up in pure data, it would look like this. Okay, so here it is, and you can see that it's missing its graphic, you know, like, so part of the way that this is actually done is that this particular system, Chamomile, actually adds those graphics in so that you can get like a nice looking VST. And this is all the stuff that it's doing here. So it's taking in the ADC, stands for analog to digital converter. That's sort of like the audio input. And then it's putting it through a couple delay lines here. And then I think it's doing some enveloping, and then it basically spits it back out, the digital audio converter. So if we use our favorite DAW, Reaper, right? Or whatever DAW you use, slightly seriously, though, within game audio, there is a pretty massive movement towards using Reaper, primarily due to just how sort of new the engine is and how you can script almost anything you want. So, yeah. So if I wanted to, I'll create a new track. I don't want to get too dogmatic about DAWs, though. So if I can load some audio in here. Let's go here. Is there, where's a good spot? Desktop. This is the thing. And if I look in the micro game, no, that won't have anything. My John Lemon. Yeah, there'll be some audio in here. John Lemon. Hello. This one. Okay, and then in assets, and then in audio, and there it is. This is a track that I worked on for a Nintendo DS game called Death Jr. and the Science Fair of Doom. Not the greatest game, but I had a lot of fun making music for it. So anyways, that's what this source is here. So take the MP3 in there, and you get your spectral analysis, which is kind of cute. This is probably going to be really loud, so let me turn it down here. And then if I want, I can add that VST effect, which is this one here. And if I open it, there it is. And see, it's got some pretty graphics which is great. So it looks nice, makes you want to use it. And then if we play the audio regularly, it sounds like this. Okay. There we go. Lots of stutter effects and stuff like that. Super into that back in the day. Now if we turn the effect on, it makes it sound like it's going backwards. Okay. So it's basically taking the envelope and then doing like a slow, attack on it. So the music is still forwards, but it sounds like it's backwards because the attack is being sort of messed with. Okay, so yeah, that is a Pure Data plugin, and if you wanted to, you would have to basically do some, like I did here, is that I compiled it. You just basically, you enter one command, it's just chamomile, and then it does the scripting and does it all itself. So then you take those VSTs that are either VSTs or VST3s, and then you put them in the right folder, and then you're good to go. And you can create whatever VST you want, assuming you know how to make it in PD, right? So there's that. I'm going to close this one down. No, I don't need to save that. And go back to the presentation. There we go. Okay, good. Just a little over halfway. Perfect. So automatism, I showed you a little bit of that already, so that's great. And it's a fun way, if you're used to working with modular synthesizers, to just get a better, whatever, to play around with virtual synthesizers. So there's also great ones like VCV Rack and other things that are free to play with as well. But if you're wanting to use it in an actual game, then it might actually be possible to compile out of this into a game using Heavy. This is just an information page, so if you're wanting to know where the community's at, you can go to the patch repository and forum. There's the link, and I'll make the presentation slides available as well, so I hope that will be helpful too. And let's go here. Whoopsies, I went 2 over. Okay, so this is a bit, it's not super, I don't know, I'll just give a general overview of it, is that what you can do with, there's sort of 2 ways to put Pure Data into games. One is that you can use libpd, which stands for Library Pure Data, and then it's like it says here, it interprets the PD patches. So unfortunately, like I was saying before, it's slow, and the PD patch is public, so people can have access to your source. But the nice thing is that it's the same as Pure Data, and it's flexible. So it can be fast enough for making apps. So this was written a while ago, and it's I used this on a game, but unfortunately, because we were using an Android platform, it was actually too slow to use in the game itself, so we actually had to drop it. So that game was called SimCell, and I have some videos talking about the details of that particular game in detail on YouTube that you can check out. And then another way of putting both graphics and audio into apps is to use Ophelia. So this is it basically combines open frameworks, which is like an open source, kind of focused on visuals, set of tools that are meant for sort of like, I guess you'd say like media creative types. So you can do interactive installations, or you can make games, but yeah, usually it's sort of oriented towards people that are doing real-time graphics, but you can also use it with Pure Data as well, and it also allows you to use the programming language called Lua. So yeah, that's a thing that allows you to use libpd and also open frameworks and combine the 2 together and make your own app, and it's quite easy enough, I guess. And there's the link there. Yeah, that's the same idea. So now we get to Heavy. All right, so maybe what I'll do here is I'll do a slight break and ask if there's any questions, and also have a small drink. We're doing good? Everybody's asleep? Awesome. Yep. Any questions? Questions? Absolutely not. Rockin'. Woo! Sweet. Yes. Okay. David, anyone? Yeah. All right. I'm going to take a second sip and then I can continue on. I can talk about
Tippy
this.
was showing off his synthesizer for a hot minute, bragging to the rest of the class about
Synthesizer.
Yeah, I noticed that you mentioned modular synthesizers, and I just happen to have one within arm's reach.
Nice.
Flexing all over us.
Yeah, those things tend to be dang expensive, but you know, they create some pretty juicy sounds. Like that juiciness is something that you can definitely get out of modular synths. I don't happen to have any, primarily for the how do you say? I don't want to get started. That's my main reason. I do like the sound. I do have like, I guess, an analog synthesizer that was a gift that I do like. That's the Pro One. I like the sound of that one, and that's sort of pre-MIDI. But yeah, overall, I do have a lot of people that I know in the game audio industry that really like the Eurorack system and have spent a lot of money on it. But you can create some really original results. And so as far as a parallel, I see, you know, pure data is kind of like, it could be sort of seen as like, if you don't have the cash for like a modular synthesizer, then you could play around with the PD side of things and get some pretty interesting results. But it probably takes a bit more effort too. So yeah.
That's
Cool.
the reason I learned Max. And when I was in college, it was 30-day free student trial of Max 4, I think. And I was too poor to buy any pedals or any processing, anything, or any modules, any analog gear. So I learned Max.
Yeah.
That's the position all these students are in now. So you guys, PD's free. Get on it.
Yeah, and that is honestly one of the reasons why I do like teaching it, is because you know, I have people that are, you know, friends that are, you know, continuing either, you know, doing university or students as well, and I guess also, you know, peers and whatnot. And the thing that can be a little bit of a hiccup with Max is that, yeah, it's a commercial product, so it does have a bit of a price tag to it, and yeah. But with that, you do get certain advantages. But for me, yeah, I kind of like the scruffiness of PD. I don't know, I'm a sucker for it. It's kind of, it's got moxie. Yeah. So yes, it's true. Yes, save your money, build your own in PD. That's true too. But you can also have the two play nicely together. You can do some really cool modular synth stuff within like a Eurorack system. So there's actually modules that use like embedded systems that you can use the heavy compiler for to compile to those systems. So like there's the Rebel Tech. The Huxton Owl, I think it's called. It's like a Eurorack module, and you can actually program PD and put it in there and do processing there. Or there's the Owl, exactly, and then there's also the Organelle as well. You might have seen the adverts for that. It's kind of this cute, like little weird box that's got like, you know, like little wooden knobs on it that you can play, and you can put PD stuff in there. So there are modules that are like standalones that can create some pretty cool stuff as well. So I didn't necessarily cover them that much here because I'm trying to somewhat stay focused on the game audio side of things, right? So yeah, you can use PD with there's specifically, it's the oh man, what is it called? Yeah, that's right. You can do Raspberry Pi, and there's other systems as well that use the Beagle hardware. I'm blanking on the name, but it's basically got really good latency to it. So it's funny. If yes, the Bella. Thank you. So yes, it's the Bella board. And so I met the folks that put that together over at Queen Mary, over in London. doing some very cool work there. So that's another thing that can be problematic about working with, basically using like DSP, like digital signal processing, is really the latency tends to be an issue. Because like what I was saying, this whole jamming thing, like if you're trying to play a chord and then you hear it like a half second later because of latency, it's pretty jarring to try and literally jam with a system like that. So the Bella is a great small microcomputer that you can put PD on and have it almost zero latency. So yeah, it's pretty cool. Okay, I'll get back to the presentation here, and then there'll be time for more questions later too. So this here is the section where I sort of show you how you can use pure data in a sort of real kind of like production level context. So the heavy compiler was basically written by two folks. So that's Joe and Martin, and they worked on it for years, and unfortunately the company didn't really survive. They tried to sell it within the sell the compiler to video game companies and other companies, and they did get some success, but they didn't get enough to be able to continue the company. So a little over a year ago or so now, the company dissolved. But the awesome thing is that they made the heavy compiler available for free, and it's open source, and that's where you can get it from. So you can download it from GitHub, and it works on Windows, Mac, and Linux. And yeah, you can also not play around with this one, and you can just register on the RebelTech website, and you can compile your own patches using that link there. So basically, they run the compiler on on the web server. You upload your patch, and then it outputs a compiled patch. Of course, part of the reason why they do that is because it's RebelTech, and they want you to use their whatever boxes and stuff like that, like the OWL. So yeah, it's pretty it's a pretty cool service that they offer there. So I can't show you this one because this one's been taken offline, but they're one of the people that worked with Heavy when it was running was Chris Heinrichs, and he made this really neat online interactive sort of, I guess you'd say, art piece for Adult Swim, where you would take, I guess it's whatever, Rick and Morty, and you'd whatever, grab the side of their head, and then it would do this sort of elastic thing. Both the graphics were in real time, but then the audio was also in real time too. So actually, maybe there's an example of his most recent one. So if I click here, there's another one where he did where it's like a chorus that's singing. Woohoo! Okay, this probably won't work, but I mean, we can try. As my computer starts to melt down. Yeah, maybe it's not gonna work. It's asking a lot. Try a different browser. No, I'll just leave it. Anyways, you can try that out at home and then let me know if it works. I think my Mac is having a hard time here running all these different things. Anyways, this is what it looks like. You pull down on the mouth, and then here, I'll just do the demo here. Right. So yeah, you can see one of the reasons why I like using PD is it allows you to do things that are really weird. And I think that's pretty weird. So yeah, the audio was all done in real time, and he figured out a way to basically make the audio happen using HTML5. So that's basically web audio. All right. So the thing with Heavy is that it compiles to different platforms. So it compiles to C, so you can use it almost anywhere. There's Bella, the thing that I forgot about. That's the processor that it uses, in case you care. Fabric is like a audio middleware for Unity. JavaScript like we saw with that last project. That's HTML5. You can also make an external PD project. So that's like, you know, Inception, like, hey, I'm going to make a PD object that makes a PD object inside of a PD object. So you can do that if you want to. You can use it with Unity. I'll try to get to show you that. VST2, that was actually different than what I showed you with Chamomile. Chamomile or Chamomile, whatever, it puts the actual patch in there and interprets it, whereas with Heavy, you actually compile it. And then Wise, I showed you that example of the ring modulator, right? Okay. So if you want to compile it for Wise, here is, and this is, you know, it's a common game audio middleware tool that this is a, there's a link to that and it shows you how to do it. Okay, once again, I will put the, like the lecture notes available for download, and that way, you know, you don't have to take notes and stuff like that, and then you can just click on it and there you go. All right. So yeah, I guess, I mean, I could show you this one. So this one is a student example. This one uses PD and it's 100% samples. So if I click on this, I'll just show you it quickly. Okay. So here's the PD patch. And it's a big monster. Rock monster, right? So yeah, it's just using samples. So that's what you can use Pure Data for as well. But you can also use it for synthesis. So this is another student, Ricardo Puyol, and with this, he simulated the sound of, you know, like a lightsaber in Unity. And so this shows how you can compile Pure Data using the Heavy compiler and use it in a game. And then it compiles down to actual bytecode, so it's actually optimized. So I'll just show you a little bit of the video here that he has, his demo reel. And is this going to play? Okay, good. Right. Right, so
for the lightsaber boost, I decided to use real-time synthesis. I created a patch in Pure Data that uses subtractive synthesis to emulate the sound as it moves. I integrated it into Unity using Fabric Audio with the Heavy compiler to convert the patch into a DSP plugin that Unity can send and receive data from. The patch contains two parameters which values are changed via script depending on the player's mouse movement. This way, the hum of the lightsaber changes dynamically in response to when it is swung around and helps make things sound more realistic than using sampled sounds.
Right, so you get a bit of what's going on there. So this is sort of what I work with the more advanced students in the school that I run, is to basically support them when they're wanting to do something really creative and interesting like that, like to make a dynamic lightsaber sound. And it took a bit of time, but now that it, you know, once you got it in, it was like, wow, that is pretty cool. And then there's this student that I won't show you the whole video, but his entire video is all done in PD. So it's all 100% synthesis, from the wind to the footsteps to the mechanical noises. What I'll do is I'll just skip around. So this is Elliot Perez. He's over in Japan. And so let's have a quick listen to this. Okay, there he is. This is his demo reel. So all the footsteps are all synthesized. Okay, and if you change materials, like what you're walking on, the footsteps change. Okay, and the water sounds are also all simulated in synthesis. And the scraping sound. And then listen to it when it goes in the water. So yeah, all of that is all synthesized. It's all just Pure Data, the entire thing. So it's a pretty cool technical achievement. And that was, yeah, basically there was a lot of back and forth on that one. And so this is a project that's available right now, and this is Pure Data plus Open Sound Control for Unity. And with this one, I will show you what it looks like. So you can, I basically push people towards the site of the school, but once you download it, then you get the, okay, let me clear, I have multiple versions of PD here. Okay, now that's probably better. Now let's open PD, and then I'll open the project. And this one will require me running Unity at the same time, so if my computer totally melts, then that's why. Because Unity takes up a lot of processing power. So let me get, okay, where would I put it? Lotus Audio, I think it's in PD. PD, there it is. And tanks, yeah, there it is. So you would basically download this. The first thing one needs to do is open up the PD project. So here it is, it's called Tanks. And yeah, this runs on the, well, I have to update it, but it will run on the most latest version of Unity, okay? And with this, it does all the sound effects and all the music, everything, the engine sounds, everything's all done in Pure Data. All right, so if I do Unity Hub, I think I've got it. Okay, so that's the micro game. I think this one's good. Yeah, I opened that up 2 days ago. So this is not necessarily the way you would work within games themselves. What you would do is that you would want to have this compiled down into heavy. But what it does right now, the way that this project is that I run Unity here, and then I use Open Sound Control as like a little connection between the two, and then I run like PD separately. And and so the neat thing is that I can actually change stuff while the game's running. So if I play the game, okay. Okay, so you hear the music, right? Okay, cool. And so the music, it will actually, let's make this a little bit bigger. The music actually talks back to the game, and it controls the height of the tanks. So that's kind of cool. And so all the sound, like the engine sound here, it's all synthesized. So if I go, and so like, and it sounds different each time. That's not a sample, right? So I'm basically putting noise through this like delay line, like this reverb, right? You hear how those pitches are slightly different, right? It depends on the frequency content and the noise that you're forcing through that process, right? So let me drive around a little bit here. And then this is my favorite here. There's a little cat sound. Yeah, that was a thing I threw in there. And now, the music dynamically responds to the game. So if I fire at that tank and the health level goes down, then the music should get more intense, right? And all those shots are all synthesized as well. See how it's getting faster? It's getting more stressed. Watch out, buddy. There, fast music. And then it slows down, but it's not sampled, so it does a smooth, transition. So I actually can change tempo very easily. So what that looks like on the Pure Data side is like this. Okay, so here's the music, and we can actually see the music changing as the game's being played. So here, there's a bass, there's a kick drum, there's a hi-hat, there's a snare, okay? And say, maybe what I want to do is I want to make this sound louder, like sort of more distorted. I could add a different process, expression, it's gonna have, I'm having a expression tan H V1, and then multiply this by something. Okay, so I'm trying to make the bass sound louder. So you notice that when I disconnected that cable, no bass sound, right? So this music is running at the same time as the game is running. So you hear now the bass should sound louder and more distorted. Okay, we can make it really distorted. See that, right? So now when I go back into the game is still running, and I changed the music basically like, you know, like the rug underneath, you know, without disturbing the table setting. Right. So now let's do this. Seem to... All right. They're freaking out. We don't have all day. All right, so we go back to this and could turn that off, turn it back on. All the things, I could change the mix, all that kind of stuff, right? So when working with like big games, that process of not having to restart the game can be huge because it can take forever to get back into a certain situation, right? So what the next step is to compile those actions that I have in those patches, the synthesis that I have in here, so that I can actually use it in a real game. Because right now, this actually takes a lot of processing to do those particular things. And, you know, it's kind of weird to have pure data running in its own thing, sort of parallel. So, all right, so let's try and do that. Okay, this goes back here. Turn the game off. And the weird thing is, what the heck? The music keeps going. Well, of course, because it's just doing its own thing. It gets data in. If it doesn't, then it's just like, oh, just keep playing, right? So I can actually turn off Unity if I wanted to, and the music keeps going. So you can download this from my site, like the school site. It's right at the top. So you can look through all the code and you can play around with that music patch. You can look at all the different synth patches, like, oh, how did the oil tank, you know, sound work? Well, let's see here. We've got this here, and basically there's like noise that goes into like enveloped, and then it gets clipped. And well, what does it sound like? It sounds like that. Okay, and we can turn the music down, or we can actually just plain delete it if we don't want to hear it. Let's just hear music. It's all in there, so I could just temporarily just delete that whole thing and go back to the oil tank hit so that we can just hear it by itself. Let's zoom in here. This is not necessarily the prettiest patch, but I'm basically taking in noise, I'm enveloping it, I'm distorting it, I'm putting it through low pass filter, through various band passes, and then I put it through this plate reverb, and that sort of gives the sense of, like, you know, that it's traveling through metal, right? It's reverberating in the metal. So if I try that, it sounds like that, and I can make the length of time that it rings out longer depending on the intensity of how hard it hits, because I can get that from the physics engine of the game, right? And it's different each time, like slightly different. So depending on how, you know, whatever, realistic or whatever you want to make it, you can tweak this to your heart's content. Okay? So there's that. I do not want to save that because I destroyed the music. Okay, so back to here. So that's what that looks like. Okay, there it is. Yes, like I said. And so what we want to get to here, oh, awesome. I'm actually on time. Okay, great. So slide 23 out of 24. We're doing great. That means we'll have plenty of time for questions and playing around, and you can ask me all sorts of stuff. So with this is the new project that I'm working on. This is the new stuff. This is the new sauce. So with this, I have a new project, a new Unity game. It's a very simple game, similar to the Tanks one. And then with this one, all of the sounds are synthesized, but I've also compiled well, what I can, basically being most of the sounds that I have in there, well, all of the sounds, they're compiled using the heavy compiler. Okay, so I'll show you how this works, and then we can ask more questions and go off in tangents and stuff like that. Okay, so I need to go back to the Unity Hub. Unity Hub, hello, where did the hub go? Come on, Unity Hub. No, we're not done yet. No, 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 I don't want to exit the presentation. My window is not showing up here. There it is. Okay, I'm going to quit it then. Let's try it again. It's the thing of trying to run multiple screens. I think it appeared behind something else. Okay, so that's here, FPS microgame, and it shouldn't be too long to load up. Boop, boop, boop. Because it's a fairly simple game. Part of the problem with this one, part of the reason why I haven't released it, the main reason being is that I haven't done the sound design, basically the synthesis for all of the sounds, but then also that Unity has, in their infinite wisdom, decided to change some of the functions that this game relies on, so it doesn't work in the current version of Unity. So I'm running an older, slightly older version of Unity. So Unity is at 2019.3 right now, and this is .2. So hopefully they'll update this project fairly soon. All right, so with this one, if I play this, all of the sounds are running in heavy, okay, including the music, which is pretty impressive, and I'll show you why. So let's do play. Okay, yeah. Okay. Unfortunately, the tempo starts out like really loud, or the music starts out really loud. So like, it'd be nice if we could fix that because it's a little loud, right? Okay. Let's turn that down a little bit. Okay. Okay, so if I wanted to change that, it's just like, yeah, that's just... Okay, well, one way to do it is I can actually do it in the Unity mixer. So if I go to Window, Audio, come on, man, Audio, Mixer, I can turn down the music in the mixer because it's actually being mixed into the Unity mixer. I was sort of smart that way, so I can go like, no, you stop. Oh, that's so much better. So now we can listen to the Ray Blaster here. So this is all using pure data. And you can hear how it gets sort of more intense as it heats up. And then it stops. And then there should be like a, like cooling off thing. I haven't added that yet. I'll get there, hopefully. Okay, so like what I was saying is it would be great if we could make the music not so distorted and loud and annoying. So let's go to where that particular project is, which is here, pure data, FPS. No, it's not. It's on the desktop. Okay, it's over here. I move stuff around a lot. Got a lot of things on the go. Okay, so here it is. And here's the pure data patch is. And so if I open up the music, let's open it up in the one that looks nice when we zoom in. Okay. I don't even hear the bass in that one. What's going on? Oh, because I need to turn the bass up. Okay, so that's great. And this will be controlled by the game. This is a parameter that's coming in from the game. So yeah, that should work out fine. Let's stop this, as much as I really love that music. And now what we need to do is figuring out how to get Heavy to take that patch and then like crunch it into something that Unity can understand. So this is kind of the point of the demonstration of like the cooking show, where it's just like, okay, here's your ingredients and then here's your final cake. And it's just like, what happened in between there? But I'll try to go through it. So what I'm going to do is, things are going to get a little technical, slightly ugly. Let's not look at that one. Okay, so what I want to do is, is if we, I don't know, bigger. Does that work? Yeah, that kind of works. Okay, so there's a lot of text here, and usually you don't want to look at text. It's kind of nasty. Unfortunately, it's the only way to do this. So let's just go like this. Let's make some more white space so that it's not as scary. Okay, so what I want to do is I need to go through the steps that are outlined in, oh man, where did that thing go? Once again, that window is like somewhere else. Okay, I'm gonna stop that and then start it up again. And then now it should be in the front, and I should do this. So these are the commands that I wish to use. Are here. Okay, view, font, bigger, bigger, plus. That's not working. Oh, there. Okay, it's like this. So it's in sort of 3 simple steps-ish. So what we need to do is we need to go to the correct directory. So that just means we need to go to the right spot. And then we're going to use Python. And that's part of the problem, apparently, that's happening with Heavy right now is that with newer versions that come out, because it's not necessarily being super supported, that it can break. And this uses an older version of Python. So you have to install, I think it's Python 7. Python is a scripting language, so the neat thing is that it gets used in a lot of games. So if you want to learn a programming language, Python is actually a good one to learn. But make sure to learn PD first. No, it's okay. I won't take it personally. So this is the program the script that we're going to run in Python, and then here is our pure data patch. That was the music one. Okay, all right. And then we want to output to this folder here. Same thing here. And then we're going to tell it like, hey, I want you to output to Unity. And you just tell it that. Okay, so we need to make sure that we're in the right spot. So CD, that's the first one here. So that's this. I'm going to copy and paste. Okay, so there we go. Now I'm in the correct. Oh, I was in there before. Okay, great. Step number 1 done. And then I'm gonna run Python, and this is what actually compiles Heavy. So I go like this, and okay, I think that worked. Not entirely sure. Okay, I'm gonna make sure by going to where that actually is. So it goes into Heavy Audio Playground, and I said put the music in here. This is where it's putting the files. And Xcode, yeah, that's good. C. Golly. I'm hoping that worked. It does look like it worked. It's like doing stuff, so that's good. And then I'm telling it to go out to this folder here. Those are just warnings, so that's fine. And the output is to HV FPS music, okay? So that's this one here. Okay, that's the, oh, actually that worked. Okay, great. See, today at 8:45, oh man, we're running out of time, crap. Okay, so the amazing thing here is that if we just quickly look at this, remember when I showed you that like music patch, right? Okay, well, this is being converted, believe it or not, into C code. And this is all written by a machine, okay? So it's like this, and keep going. Oh, no, we're not done yet. We're not done yet. This is all the music. So this is what Heavy does for you. So, you know, that's why it's nice to have Heavy working on our side, okay? This is all the code that gets compiled, okay? Okay, we're almost done. Okay, done. Okay, so great. We're taking that, and then that compiles down into something that we can use for, there we go, yes. And so that made those C files, and then now what we want to do is we want to do the last bit here, and we want to use Xcode, which compiles that C code that we just saw, and it converts it into stuff that the computer can actually read. Okay, so once again, lots of text. Build succeeded. Oh my goodness. Okay, this is great. Okay, I actually am happy about that. Okay, so now see, we have a build folder. This is 2 minutes later. Oh, wow. Okay, and now I look in here, and eventually I got a bundle and a CS. So that's C# script. That's the interface that Unity needs. Okay, and I need to put that in the right spot. Okay, quick. All right, this desktop. Okay, here, and we do this. It goes in here. All right, and I actually know that I haven't changed the CS, so I don't need to put that in there, but I do definitely need to put the plugin into the right spot. So here we go. I take that, and it should be replacing an existing bundle. Okay, so we copied into there, replace. That's good. So now when I go back into Unity, actually I should probably, I mean, it might work. It would be weird if it did though, but let's try it anyways, because I'm changing the code as Unity's running, and usually it does not like doing that. So if the music is quieter, then it worked. Okay, it's very quiet because I muted it. Okay. Now, it's too loud, so let's quit Unity, start it again. I really want to get this to work because I think it's kind of interesting. Okay, there's that, close that. Oh, hub, so many things. Okay, this, and this better work. Okay, now we're loading it again, so that means it should load the libraries in other words, the little chunk of code that we made, that little bundle file. That's where all our good stuff is happening for the music. Okay, and now when we play, hopefully it will have changed that. Okay, stop. Sorry, Zoom is competing with me here. All right. Ooh, that's great. Yeah, so there you go. Now it's not distorted anymore, right? So now we have the music the way that we want it. We go here. Remember those droids talking at the beginning? I reused that patch for that droid. So that's a neat thing about using synthesis and code is that you can reuse it and tweak it and stuff. Oh man. Okay, that works too. Great. All right, there we go. I actually did close it. Okay, thank you very much. Yeah, nothing like little claps. Cool. All right. So yes, now we'll do some questions.
Oh. Hi. If
Hello.
I don't know if anyone, yeah. So just I get that, like, compiling it, turns into C++ code and whatever that, Unity can read. But I wasn't quite clear on the whole process of, like, actually getting the connection between, like, Unity and Pure Data in order to kind of, like, prototype it and build it in real time in the first place.
Oh, okay. So you mean like the tanks project?
Yeah.
Okay, so that uses basically open sound control is very similar to MIDI as far as a format. And so basically it's kind of like using MIDI between the two to communicate. So they're actually running in separate programs. And so with that, I'm using, open sound control as like sort of like MIDI to talk and say like, oh, hey,
Okay.
you should make the tanks go up and down. Okay, great. Well, now that the tank has this much damage, you should change the music like this. Okay, great.
Okay.
I'll do that. So if we look into like there's actually a section here that I do open sound control event system where I actually take information like from the game, and it's bidirectional, so it means you can send it both ways, from Pure Data or back to PD. So I would basically recommend like looking at the project, and then you can see how it's done as well.
Cool.
Here it is opening up in Visual Studio, which is taking its sweet time. Because, I don't know. I guess I could probably close that thing. Okay. Yeah, it's not really wanting to not really wanting to run very quickly on this machine.
Mm.
I could, oh, there it is.
Okay.
So yeah, see, so what I've done is I've taken existing code and then I've sort of
Yeah.
hacked it into doing what I want. And so you can actually run like the pure data program on a separate computer. But in this
Uh-huh.
one, it's actually using the same IP, like the internet, address. So
Yeah.
this is like that's called a loopback. So you can run it on the
Mm-hmm.
same machine. But
Yeah.
yeah, you could actually run, your friend could be running the PD side and someone else you could be running the Unity side. So yeah, you can
Cool.
basically look at the code. It's not
Yeah.
super complex. So
Mm-hmm.
that's how it does it. Yeah,
Cool.
nice.
Thank
Questions?
you.
I got cheers, thanks. Like the chat. Oh no. Yeah, there we go. Yep. Uh-huh. Yeah. Kale's good. All right. Any questions from otherwise, like from YouTube, I guess? I don't know.
How did you get started in programming? What came first for you, music or programming?
Oh, yeah. Well, yeah, I mean, definitely music. Yeah, so I went to Montessori as a kid, and there's always been, like the different stations and stuff, and I was super jazzed about the music one, like the shakers and different, like really simple instruments that they would give kids. So yeah, I was very interested in that. And oddly enough, my half brother who lives in Trinidad, he was the producer for like the song "Hot Hot Hot." So like Buster Poindexter did a version of that, but there was a previous version that was done by my half brother Leston Paul, and he's actually quite a big soca producer still down in Trinidad. So maybe music kind of runs on that side of the family as well. But yeah, I don't know. I think that came first, and for me, programming is just it's kind of like it's like extended technique. It's like how to take my ideas even further than what is kind of conventionally possible. But yeah, like I really view code as a means to an end.
Mm. I love programming for similar reasons. It keeps you from being put in any kind of box about how music is supposed to be organized and how we should be organizing sound. It's very open-ended, and you can have a really specific thing you want to do. And also, for me personally, it helps me a lot to get out of a rut. It helps me find a creative space for myself musically that I can't do in a DAW. Just can't.
Yeah, no, I find that the same thing when I'm not a guitarist, but when I typically compose a lot on the guitar, and so when I pick up the guitar, sometimes I'm like, I was just here. Like my mind kind of does the snap of like, oh yeah, seventh chords, and then I'm like, okay, I got to figure out something else. So a whole other part of my process that I didn't describe for games is I do a lot of chiptune stuff. So that's basically using old video game consoles as instruments.
Mm-hmm.
And with that, I would sort of figure out stuff on the guitar and then like sort of arrange that for like using a tracker, like a composition program for those old systems, and figure out how to sort of, I guess you'd say arrange like, like a guitar, riff or whatever, an idea that I had. And then by the time it comes out on the other side, it's totally different and often kind of odd. So yeah, I really do like taking like an idea from one domain and transposing it to another domain.
Yeah, totally.
Mm-hmm.
Yeah.
Yeah. So yeah, these days I want to get back more into music. Doing the like part of why I did the beat score was because a lot of people were like, "Oh, hey, you like Pure Data? You ever do like music in it?" And I was always like, "Hell no! What are you nuts?" Like, so I actually took it on as a challenge, and Yeah, like I don't know if I necessarily super need to go there again, but I do like using the Leap Motion for performance, and I just like the sort of, the feel of it. But yeah, like these days, yeah, I want to do some like chill hop stuff. I got a Digitac and I'm just sort of playing around with that, and I want to try some weird stuff, maybe, using PD as a way to make arpeggios or, like munge up samples and things like that. So yeah, I like trying to figure out different uncomfortable places to push myself into as a composer.
Yeah, I think that's for me also like the key to keeping it interesting for sure.
Mhm. Yeah, and I think that's actually a big thing with there's a lot of sort of stories and stuff, but I think Brian Eno was like sort of famous for that, to push musicians into uncomfortable spots, to have them produce really original artwork where you're just like, why, how did this ever happen? And then you look at the process and you're just like, oh, okay. And it's funny because you listen to the music and you're just like, oh, that's so interesting. Meanwhile, the musicians are hating it. Like they're not having like, they're just like, they're not able to like lean back and go like, oh, I just play the guitar and I do this thing. Same with like, what was it, Keith Jarrett, like the Colne concerts where he's like moaning because he's just like, this piano's killing me. But like the music is beautiful because he's basically like bashing his head against a like, in that sort of artistic process. But that process, to listen to it, is also like such a beautiful thing, to be on the edge. And so yeah, I try to find that spot in my own work. And I think actually honestly the other folks that, I'm gonna tune in as well, the other composers and, artists that you brought in, like I think that they have a very similar way of working as well.
Yeah, that's what we're all about here in TAC. We're all about that kind of expansive, what is possible, tinkering into the willpower of a mad tinkerer to make a beautiful thing that is full of polish and rigor and excellence and all of that.
Yeah.
Got some great composers here in the room today, and I know they all really enjoyed your lecture today.
Oh, thanks.
Thank you so much for your time and sharing all of your work with us. We loved having you, and we hope next time we see you, it's in real life.
I know. I really tried. Like I canceled like the day before my flight. Like
I
I'm
know.
just like, oh man, come on. Like
Yeah, that was a really crazy day when we talked on
it
the
was.
phone and made that decision. But I'm glad you're here now with us
Yeah.
in Zoom land. And we'll feel free to tune in for any of the other stuff. We'd love to have you join us and chat us up on YouTube. Continue the hang.
That sounds great. Yeah, well, thanks so much. And yeah, I guess if anybody wants to get a hold of me, I'm available at that web address. There's an email there, or I'm available on Twitter. Just look me up online. You can find my name. And yeah, it'd be great to hear from you. So I hope that we can continue the discussion. And thank you so much for inviting me. It's been a great time.
Awesome. For everybody tuning in at YouTube, we will continue the party tomorrow with our masterclass with Austin Wintory from 2 to 4, and our evening lecture demonstration with clipping from 7 to 9. You can find out more details at bit.ly/SFCM TAC. Take care, everybody, and we'll see you tomorrow.
Thanks. Great. Cheers. Bye-bye.
Bye.